So now in this video we will be talking about ionic bonding. I'll be sharing with you, of course, how does it happen, in what kind of substances does it happen, and about the properties of ionic compounds. So let's get to it. Firstly, you need to understand a bit more about metals and non-metals over here. So let's take a simple example of lithium and fluorine. So lithium is a metal. Why I'm taking lithium is because I don't want to draw too many electrons. Yeah, so pardon my laziness. And fluorine, fluorine is 9. So 2, I'll do dots. And 9, 7, 3, 4, 5, 6, 7. So lithium and fluorine, right? What you realize here is that lithium has got only one valence electrons, means it either needs to take in 7 or lose 1. Fluorine needs to take in 1 or lose 7. I hope you understand what I'm talking about, right? So if lithium, for example, takes in 7, this outer shell here will have 8. Or if it loses 1, this will become the outer shell. Fluorine, on the other hand, if it takes in 1, this outer shell here will have 7, or if it loses 7, this one here will have 2. So this will become the outer shell. Now, which one is easier? What will the atom do? Will lithium take in 7 or will it lose 1? I hope you can see it's easier to lose 1 than take in 7. Fluorine is easier to take in 1 than lose 7. So that is why metals tend to donate electrons and non-metals tend to take in electrons. Okay, now you should understand a bit about ions at this stage. I'm not going to go into detail, but you must understand why is it that metals form positive ions and non-metals form negative ions. If at this stage you don't understand this, please watch our video on atoms, molecules, and ions and you will understand more. Okay, so now back to lithium and fluorine. Lithium forms an ion of Li plus because it loses 1 electron. Fluorine forms an ion of F minus because it takes in 1 electron. So now let's move on to, from this Li1 plus, there's a reason why I'm putting the 1 there to make it easier. What is the formula for this molecule? This goes down over here, this 1 goes down here. You get LiF. So that one lithium ion and one fluoride ion, they combine together to form lithium fluoride. What if, for example, we have like Mg and F, where Mg is 2 plus, F is 1 minus. So you bring this over here, you get MgF2, right? So the molecule is MgF2. And this is the first thing you need to do. First thing you need to do is find out what is your molecule, right? Now we can work on the dot and cross diagram. Let's do it for LIF, and let's do it for something a bit more complicated where we have Al and oxygen. So Al is 3 plus, oxygen is 2 minus. You bring this over here, you bring this over here. You get Al2O3. Okay, let's do the dot and cross for these two molecules. So for LIF, we saw earlier that lithium is lithium. It will have 2. You put a bracket and then you put plus because the lithium has lost 1 electron. And then for the fluorine, you have 2. very clearly differ because they are different electrons. 4, 5, A here. And then here you put minus. And then you need to draw a legend. This is electrons from lithium. This is electron from fluorine. Okay, so this is your dot and cross diagram for lithium fluoride. Okay, very simple. Again, here you can see both of them. You can see that the outer shell is full and that they have lost or gained their electrons, and that is shown in the charges over here. Now Al2O3, aluminium has got 13 electrons, right? So you know that it will lose 3 electrons. So Al, so right now it will have 10 electrons. 13 you lose 3, you get 10. So you draw 10. Bracket 3 plus. How many of it? You have 2 aluminium ions. Okay, I don't have too much space, so I'm going to do it a bit smaller. Oxygen, it has 8 electrons and it gained 2, right? Because it has 6 in the outer shell. So it gained 2 to form 10 electrons. So oxygen, again, I'm going to draw smaller. So pardon me. 1, 2, 3, 4, 5, 6, 7, 8, plus a 2 inside, you get 10. You put here, you get 2 minus and 3 oxygen ions. And this is your dot and cross for aluminium oxide. Yeah, that's it. So it's really that simple. It's not very difficult to draw the dot and cross diagram, especially for the ionic compounds, and I hope really you understand. Now we'll be moving on towards the properties. So all right, so the important thing to know is that between your ionic compounds, let's take this as the positive, negative, positive. These are your ions, right? This will be a negative here, there will be a negative here, there will be a positive here, positive here. They are all bonded like that. And it continues. So, and there will be another one here, there will be another one here, another one here. So, like that, right? And then this is here, here, this is here, here, this is here. Okay, I hope you get the picture. So they're all bonded like in a cube, like that. Okay, let me just complete it so it's and it goes on and on. So these bonds here are what you call electrostatic forces, and these electrostatic forces are very strong. Okay, now these are in the ions, ionic compounds. This is an ionic compound over here, and it has what you would call a giant ionic lattice structure. Giant ionic lattice structure, which is made up of electrostatic forces that are very strong. So understand this part because it is essential to understand why some of the properties of ionic compounds. So first property, they have high melting point and boiling point. Now you have to understand something. If something has high melting point and boiling point, the reason is that it takes a lot of energy to break the bonds. So you explain this by saying electrostatic forces between ions is very strong. Okay, so what? So lots of energy is needed to break bonds, and so high melting point and boiling point. Okay, so electrostatic forces between the ions is very strong, and so a lot of energy is needed to break the bonds, and therefore it has high melting point and boiling point. Okay, second thing, ionic compounds can conduct electricity when in molten or aqueous state. Okay, if you don't understand the difference between molten and aqueous state, molten is when something melts, aqueous is when you put something in water. Okay, molten is, for example, you have sodium, or no, let's just say you have ice. Okay, no, let's not put ice. Okay, when you have a piece of solid and you heat it up until it melts, that becomes molten. However, if you have a piece of solid and you put it into water and it dissolves, that becomes aqueous. Okay, so again, a bit more, molten is basically a pure substance, aqueous is a mixture. Okay, now when you have an ionic compound, for example sodium chloride, which is your table salt, you put it as a solid, it will not be able to conduct electricity. But when you heat it up and it becomes sodium chloride liquid or sodium chloride aqueous, it will be able to conduct electricity. Now why? This is because in the molten and aqueous state, I'm going to just write down the important parts. All right, in the molten and aqueous state, ions the molten and aqueous state has got free and mobile ions, or you can also say that the ions are able to move about, right? And because of that, because the ions are now able to move about, they can conduct electricity. So that's the most important thing. The ions are now able to move about, and so they can conduct electricity. Now the third point and the fourth point, they are slightly advanced, so I think it's just good for you to know. Ionic compounds are generally soluble in water but insoluble in organic substances. So generally soluble in water but insoluble in organic substances. Okay, and lastly, the fourth point that you must know is that the bigger the charges on the ions, the stronger the electrostatic forces, and so the melting point and boiling point is higher. For example, if you have MgO, magnesium and oxide, right? So you have magnesium 2 plus, oxygen 2 minus, you bring it down, but you realize that the charge is there are two electrons being transferred from the Mg to the O, and you have another one, NaCl. Na is plus, Cl is minus. There's only one electron being transferred. Now the melting point and boiling point for MgO will be higher, and this one will be lower. Why? Because there are more electrons being used in the transfer. So that is the fourth point. Again, this is slightly a bit advanced level. So that's it for this video for ionic bonding. I hope you understand how to draw the diagram and the properties of ionic compounds. So that's it. Bye bye.